Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through my last video in which I have explained what is HCF and what is LCM and how we can calculate HCF and LCM of numbers given to us. So that was the first part of the HCF and LCM. In today's video, we'll continue with that and we will be solving some word problems on HCF and LCM. So let us start with that. In this video, we'll be seeing some question and its solution, but I would request all of you to do the question from your end first and then to check the solution. So the question here given is, find the number between 300 and 400 which leaves remainder 5 when divided by 14 or 35. So there is a number between 300 and 400 such that when that number is divided by either 14 or 35, we get a remainder of 5. So can we say that if we take the LCM of 14 and 35, I'll be getting the list number which would be divisible by either 14 or 35. Then we can try to find the multiples of that LCM in between 300 and 400, and then we can see which number when divided by 14 or 35 will give the remainder 5. So let us first try to find the LCM of 14 and 35. So 14 is nothing but 7 times of 2 and 35 is nothing but 7 times of 5. So we can say that the LCM of 14 and 35 would be 7 times of 2 times of 5, that would be 70. So that means 70 is that list number which is divisible by 14 and 35 completely. So now if we check the multiples of 70, that is the next multiple would be 140. That means 140 is also divisible by 14 or 35. Now we need a number between 300 and 400. So let us try to check the multiples of 70 which falls between 300 and 400. So the next would be 210, next would be 280, and then we'll be having a number 350. So that means 350 lies between 300 and 400, and 350 is that number which is divisible by 14 or 35. But we need to have a remainder of 5. So let us simply try to add 5 to it. So the number would be 355. So that means 355 is that number which is divisible by 14 or 35 and leaves a remainder of 5. So in such kind of questions, simply we need to take the LCM and add the remainder to get the final answer. Okay, so now let us try to see the next question. The question says, find the list number which leaves remainder 2 when divided by 3, 4, 5 or 6 and is completely divisible by 11. So if you look closely, if we remove this part, then the rest of the part is similar to the question which we did a few minutes back. So let us try to calculate the LCM of 3, 4, 5 or 6. So the LCM of 3, 4, 5 and 6, if you calculate, this would be 60. So that means 60 is that number, is the list number we can say, which when divided by 3, 4, 5 or 6 is completely divisible. But it leaves a remainder of 2. So we can say that 60 plus 2, that is 62, is the list number which is divisible by 3, 4, 5 or 6 and leaves a remainder of 2. But we need to find that number which is also divisible by 11. So let us try to calculate the multiples of 60 in this case. So the next multiples of 60 would be 60 times of 2, which is 120, but we need to have a remainder of 2 as well. So this would be 122. But if we check whether it is divisible by 11 or not, so if you see 11 is not dividing 122 completely, so we cannot say that 122 is that number. So now let us go with the high numbers. So let the third number would be 60 times of 3 plus 2. So that would be 182. Again, if you divide 182 by 11, we can see that it is not divisible by 11. So let us go to the next possibility. So this would be 60 times of 4 plus 2, which would be 242. Now, if you divide 242 by 11, so that would be 11 2. So 22 and 22 again. So this would be 11 2s. So since 242 is completely divisible by 11, so we can say that 242 is that smallest number which is completely divisible by 11, and when this number is divided by 3, 4, 5 or 6, the remainder we get is 2. So our final answer is 242. Okay, so now let us try to see these two sums. So the first one says, find the list number which leaves remainder 3 when divided by 5, leaves remainder 4 when divided by 6, and leaves remainder 5 when divided by 7. The second question says, find the list number between 200 and 300 such that when the number is divided by 8, the remainder is 4, and when the number is divided by 9, the remainder is 6. So you can see in both this question, there is some similarity. But if you look here, the divisor is 5 and the remainder is 3. The divisor is 6, the remainder is 4. The divisor is 7 and the remainder is 5. So if you check the difference between the divisor and the remainder, which is 5 minus 3, that is 2. Again, 6 minus 4, that is 2. And 7 minus 5, that is 2. So in such cases, when the difference between the divisor and the remainder is same, in that case, we can simply take the LCM of all the divisors. So in this case, we need to take the LCM of all the divisors, that is 5, 6, and 7. So if you take the LCM of 5, 6, and 7, so this would be simply 210. So 210 is the LCM of 5, 6, and 7, or in other words, we can say that 210 is the list number which is divisible by 5, 6, and 7 completely. But here the difference of the divisor and the remainder is 2. So whatever the LCM you get, simply subtract the difference of these numbers from the LCM. So 210 minus 2, that is 208, and 208 is the final answer. You can check it out as well. When 208 is divided by 5, the remainder is 3. Yes, it's correct. Again, when 208 is divided by 6, the remainder is 4. This is also correct. Again, when 208 is divided by 7, the remainder is 5, which is also correct. So in such cases, when the difference between the divisor and the remainder is same, we can simply take the LCM of the divisors and subtract the difference of the divisor and the remainder from the LCM, and that would be the final answer. Okay, so now let us try to see this question, which says that we need to find the list number between 200 and 300, such that when the number is divided by 8, we get a remainder of 4, and when the number is divided by 9, we get a remainder of 6. So in this case, the difference of the divisor and the remainder, 8 minus 4 would be 4, and 9 minus 6 would be 3. So in this case, the difference is not same, so we cannot apply this method. So we need to apply another approach in such kind of sums. So we need to find the structure of numbers which will be following this condition. Now, since the number is divided by 9 and the remainder is 6, so we can write the number as 9 times of some quotient plus the remainder, as any number can be written as divisor times of quotient plus the remainder. So using that, we can write the structure of this number as 9q plus 6. Again, if we use the first condition, which says that the same number when divided by 8, we have a remainder of 4. So let us try to restructure it and write it in this form: 8q plus q plus 6. So the same number can be written as 8q plus q plus 6. Now, when we divide this number by 8, so the whole number would be divided by 8. So this can be written as q plus 6 upon 8. Now, whatever the remainder we are getting 4, we are getting from this part. So that means when q plus 6 is divided by 8, we should get a remainder of 4. Now, if we do some hit and trial, we can see that the list number of q for which such condition will exist would be, q would be 6. As when q would be 6, 6 plus 6 would be 12. 12 by 8 will give us a remainder of 4. So the list number which follows this pattern would be nothing but n equals to 9 times of 6 plus 6. So that is 60. But if you want to find the structure of the number which follows this condition, in that case, the structure of the number would be 60 plus some constant, let it be k, times of LCM of 8, 9. In our case, this would be 60 plus LCM of 8 and 9 would be 72. So this would be 72k. So that means the structure of the number would be 60 plus 72k. So now, since we need to find the number between 200 and 300, so let us try to put the value of k in such a way that we get the list number between 200 and 300 and which follow this condition. So this will be happening only when we put k equals to 2. Because when we put k equals to 2, this would be 144 plus 60. So the number would be 144 plus 60. So that would be 204. Remember, there can be some other number between 200 and 300 which follow this condition, but we need to find the list number. So we need to put the list value of k such that we get the list number which follows this condition. So let me repeat this once again. When the difference between the divisor and the remainder is constant, we'll be following the first approach. That means we'll be simply taking the LCM of the divisor and then we will subtract the difference from the LCM. So that would be the final answer. But in the second case, when the difference between the divisor and the remainder is not same, in that case, we'll be trying to structure the number and then we can find the list number or whatever the number been asked. Okay, so now let us see another question. The question says, find the greatest number which leaves remainders 10, 8, and 6 when the number divides 70, 80, and 90 respectively. So there is one number which is dividing 70, 80, and 90 and leaves remainders 10, 8, and 6. So can we say one thing, that 70 minus 10, which is 60, 80 minus 8, which is 72, and 90 minus 6, which is 84. So all these numbers are completely divisible by that number. So now we need to simply find the greatest number which is dividing 60, 72, and 84. So indirectly they are simply asking us to find the HCF of 60, 72, and 84. So 60 we can factorize as 12 times of 5, 72 we can factorize as 12 times of 6, and 84 we can factorize as 12 times of 7. So what is the common between all these numbers? So here it is 12. So we can say that the answer of this question is 12. That means 12 is the highest number which is dividing 70, 80, and 90 and leaves remainder 10, 8, and 6 respectively. Okay, so now let us see another question here. So the question asks, find two numbers which have HCF as 6 and the LCM as 90. So we need to find two numbers such that their HCF would be 6 and their LCM would be 90. So let us assume that two numbers are 6a and 6b. Why I'm considering it as 6a and 6b? Because the HCF is 6, so we can say that both the numbers would be multiple of its HCF, that is 6 in this case, and there has to be some multiple. So in the first number, I'm taking that multiple to be A, and in the second number, I'm taking that multiple to be B. Again, in this case, if you notice, A and B has to be co-prime numbers. Now, what are co-prime numbers? Co-prime numbers are those numbers whose HCF is 1. Why? Because all the factors will already be considered in the HCF 6. So A and B has to be co-prime. That is, their HCF has to be 1. Now, in the previous video, we have learned one thing, that is product of two numbers is equal to the product of their HCF and LCM. So can we say that N1 times of N2 would be equal to 6 times of 90, or 6a times of 6b would be 6 times of 90, implies a into b can be written as 6 into 90 upon 6 into 6. So this would be 6 cancel and this would be 50. So that means the product of two co-prime numbers AB would be 15. So now we need to check the possibilities in which the product of two prime numbers comes to be 15. So what are those possibilities? I can take A to be 1 and I can take B to be 15. And what can be the other possibility? I can take A to be 3 or I can take B to be 5. Well, some of you might think that I can take A to be 15 or B to be 1 and A to be 5 and B to be 3. Well, in both these cases, we'll be getting the same pair of numbers. So you can take either way. So now, if I take A to be 1, B to be 15, what can be the possible numbers? N1 can be 6 times of A, so that is 6. And N2 can be 15 times of 6, so that would be 90. Again, if I take A and B to be 3 and 5, in that case, N1 can be 6 into 3, that is 18. And N2 can be 6 into 5, that is 13. So there can be two pairs of numbers which follow this condition. So one pair is 6 and 90 and the other pair is 18 and 30. Because 6 and 90, the HCF would be 6 and the LCM would be 90. Again, 18 and 30, the HCF would be 6 and LCM would be 90. So in such kind of questions, we can simply use product of two numbers is equal to product of HCF and LCM, where the two numbers can be taken as HCF times of some number and the other number can be taken as HCF times of some other number, where these two numbers A and B are co-prime. That means their HCF is 1. Okay, so these are some basic examples which I have taken to show you the kind of question that is being asked from HCF and LCM chapter in the competitive exam. But I would request you all to practice more and more such questions, because the more you practice, the more you learn. If you have any confusion, I would request you to see the video again and to practice the questions once more. But still, if you have any doubts, please put it in the comment box. I'll try to answer each one of your queries. So if you like my videos and want me to make more such kind of videos, then do subscribe my channel and share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.